Let's look next at where the code is coming from. And different sources of code come from with different characteristics. There's different pros and cons associated with them. We'll look at 4 here, the first of which is legacy. So legacy code clearly comes under the company's core development processes. But here, actually, because it's been developed over many, many years, typically, there's inconsistency and the code tends to be a little bit fragmented. It's not necessarily aligned to today's processes and all the best practices that are being used to develop today's code. And also very occasionally, there's problems with the tool chain. In the parts of the tools that are needed actually become obsolete and are no longer available and supported for development. Often also, you find that the developers or the key individuals who know the code are on new projects, or they've gone to new companies, or they've retired, or they've run off to Spain with a belly dancer, or they could be anywhere. You're not going to get them back. So it's not quite the same as your normal code. The other thing that's often said about legacy code is that it's proven in the field and therefore automatically suitable for reuse. I think the lesson learned from safety-related systems is certainly that's something to take with caution. Certainly if it's different target hardware, or the code's going into a different system or a different environment with different edge cases, actually, if you need to be very sure, just assuming proven in the field is going to migrate is something that can't be done lightly. From a static analysis tools perspective, clearly there's a role here for the tools to give greater insight into the structural integrity of the legacy code. At one extreme, the code could be absolutely sound and absolutely suitable for reuse and maintainable and understandable. At the other end of the spectrum, it could be spaghetti, very poor quality and code that you definitely don't want to use, you want to bin, and you want to rewrite this from new. Alternatively, you might decide it's a black box approach. You're not really happy with the code in the box, but you're happy with the inputs and the outputs. Most commonly, the approach is to use the tool, and there's mechanisms, a standard to update, to get the tool updated to comply in an incremental way to today's coding standards. Each of those has a clear impact on the ROI and also the risk. The second area I'd like to look at, keeping the theme of food here a little bit, is open source. So it's free and also commercial code. Clearly here, the source code is also visible to the development team. The big issue here is knowing the provenance and what the confidence is, especially in the quality of the code and the ongoing support. Actually, if you look at some open source areas, and I use Hudson and Jenkins here as an example, there's commercially hardened variants of open source projects. So Hudson have taken Jenkins and they've said, look, we will make sure that this part of the code is very well supported and we'll update the quality and we'll look after it. And then when you as a customer use this code, you can do so with much more confidence. Some vertical markets are also looking at this issue because clearly there's incentive of using open source. So in the medical field, they call it SOUP, software of unknown pedigree. And in the A&D space, they talk about COTS, commercial off the shelf. But the logic's the same. How can we leverage this code that's already been created without reinventing it? Third area I'd look at, auto-generated code. Very interesting in that the developers can actually see the code, but clearly they can't change it directly. To make a change to the code, they need to go back to the model, rerun the model, which regenerates the code. Of course, there's manually created code that fills the gap between the auto code as well. And that handcrafted code, they need tools to work effectively to access and identify the handcrafted code and let them change it and keep it up to the best practices and the coding standards. One interesting insight from a couple of customers that we have with small code bases is they've used model-driven development, but just for the design, the visualization, and the actual modeling. They haven't taken the next step to do the auto-generated code. What they've done is taking the model but actually generated the code by hand. That way it's easier to maintain and easier to verify. Fourth area to look at finally is outsourcing. Outsourcing has been used for a very, very long time by business operations, call centers, IT outsourcing, and clearly the business model's there. You can deliver the same job at a much lower cost. And in more recent years, clearly from an engineering perspective, development teams are also outsourcing to a much, much higher degree. And outsourcing is good in that it helps to manage peaks and troughs and resources. It gives access to specialist skills. Potentially it allows work to happen around the clock by using the different geographies around the world, and it will deliver lower cost. One of the big issues is guaranteeing that the code quality comes back at the level that it needs to be. And clearly there's a role here for outsourcing for using static analysis tools. The two examples I would identify here, one is automotive. The OEMs typically describe themselves as systems integrators, and they put a lot of the onus on their supply chain to supply all those components. And they use ISO 26262 and MISRA to help to prove the structural quality of the code that they're receiving from that extensive supply chain. The second one to mention is the transition from development to support. And in this environment, if the support team inherits structurally sound code, it becomes very easy for them to maintain, or relatively easy for them to maintain. If they inherit spaghetti, actually they can have a really, really tricky time because they've got huge liabilities and huge risks, and life becomes very tricky for an outsourcer with spaghetti code who's trying to do support.